Okay, so let's talk about another three sigma notation problems. Basically, it's a summation problems. Okay, so look at the first one. Um, Summation from 1 to 5 n times 2n plus 7. Okay, so we can have at least two ways to think about this problem. But a straightforward way, it might be you distribute this, give you 2n squared, right, plus 7n, and then just plug in 1, 2, 3, 4, 5. The other thing what you can do is, guys, you can do based on the summation property. We can here has 2n squared, right, plus summation n from 1 to 5, 7n. Also, right, so this is the sum law, and you can use a constant multiple law to bring those constant out. That are gonna give you is 2 times n to 1 to 5 n squared plus 2 5 here is 7 times n. Okay, times n. And eventually you can do is you can apply the sum of first n integers into this problem. That are gonna give you 7 times 5 plus 1 times 5 over 2. Okay. And I believe this part is 15. This part is 7 times 15 give you 105. Okay. For this part, you also have a formula here, guys, which is summation of n squares. It's gonna give you its let's see, this is a 5. Oops. Let's see, yeah, times 5 plus 1 times 2n plus 1, which is 2 times 5 plus 1 over, I believe it's over 6. Okay, over 6. So let's see. So you have 11 here. Here 6 over 6 is gone. Times 5. So it's 11 times 5 is 55. This part is 2 times 55 gives us is 110. This part gives us is 105. So this we're gonna have is 215. Okay. Be careful, guys. This we are actually using 2 of the summation formula. Let me write it here. So the sum of actually n starting, well, maybe let's use a different notation here. K from 1 to n, k. This is the sum of the first n integers. It's n times n plus 1 times n over 2, okay? This is one of them. And if you have the summation k from 1 to n, it's a little bit crowded, guys. Okay, I apologize. So for example, it's 1 squared plus 2 squared plus 3 squared up to n squared. So you're gonna have this n times n plus 1 times 2n plus 1 over 6. Okay, so this is another no summation of the first n cubic, like 1 cube plus 2 cube plus 3 cube up to n cube. It's the answer is should be easy to remember, which is n plus 1 times n over 2, then big parentheses square. Okay, but I won't write them out. Now let's look at the second one. K from 7 to 30, square root of k minus 4 minus square root of k minus 3. Okay, so this kind of problem, guys, if you look at the structure, first of all, it's the difference of 2 terms, okay? And also, you can also tell that inside of the radical, there is a difference. Actually, it's 1, right? Or -1 depends on which one minus which. Okay, so under this kind of scenario, often you will encounter a lot of cancellations. Okay, so we write it out. Well, let's take a look here. So when k equals 7, you have square root of 7 minus 4 is 3, right? Minus square root of 7 minus 3, which is 4. So this is when k equals 7. And then if you do plus when k, so this is when k equals 7. Let's see when k equals 8. So you have square root of 8 minus 4, which is square root of 4, minus square root of 8 minus 3, which is square root of 5, right? And this is k equals 8. Well, let's write one more. So when k equals 9, you're gonna see that you're gonna have square root of 5 minus square root of 6. And as many of you can see, do you realize that actually I have -4, I have +4, or square root of 4. So those two is cancel. You have a minus square root of 5, I have plus square root of 5, right? Those two cancel. And it's kind of like a telescoping cancellation here. So later on, you will see, guys. Let's write it. Let's put a lot of here. Let's write when k equals 29. So you have square root of 25, right? Minus square root of 26. So this is when k equals 29. And then let's see, k equals 30 equals what? You have square root of 26 minus square root of 27, right? This is when k equals 30, okay? Sorry about the space. It's very crowded. And do you see that, guys? This negative square root of 26 and positive square root of 26 also cancel out. So there are only 2 survivors for this summation, which is the first one and last one, okay? And if we put them together, they're gonna give us is square root of 7 minus square root of 27. And a square root of 27, which can be simplified into 3 times square root of 3. And you do a little bit of calculation, they're gonna give you -2 times square root of 3. Okay, so that's the second problem. Okay, so telescoping. Okay, all right. The other problem. Let's look at it here. I ask you to figure out the summation 11 plus 12 plus 13, up to 100. Okay, and I'll introduce 3 approaches for solving this problem. Okay, the first way is we need to use a formula here, guys. Okay, so since we know that the summation of the first n integers is n times n plus 1 over 2. Again, guys, starting from 1, okay, so it's 1 plus 2 plus 3 up to n. It gives you this. But what we have here, it does not come across from 1, okay? So how do we do that? Well, we can think about it, the problem is like this. Okay, so do you agree that for this, we calculated the summation from 1 to 100, right? And if I make a subtraction about the summation from 1 to 10, do you see that this is what I got, right? This is what I have here. And you can calculate this as 100 times 101 over 2 minus 10 times 11 over 2. So this is 5050, I believe. This part is 55. So the answer gives you is 4995. Okay. So this is the first way to think about it. Okay. The other way to do this approach is to use the idea for deriving this formula here. Let's take a look at it here. 11 plus 12 plus 13 plus 98 plus 99 plus 100. Okay. If I rewrite this summation into a decreasing order, that is going to give us is 100 plus 99 plus 98 plus 13 plus 12 plus 11, right? And as you can see, guys, if you add this together, they're going to give you it's 111. If you add all this together, it's going to give you 111, right? You add this together, it's going to give you 111, right? So you can always add all of them together. So think about this, the sum of all these numbers, okay? In other words, I add our summation twice, right? Because this is once, this is second times. So, but with this pattern, I can easily to calculate it. The summation of this big bunch of pieces is going to be 111, right? Times how many 111 I have? Well, it turns out it's 100 minus 11 and then plus 1, which is 90, right? So this is the summation of all these pieces. But what I want is a value of 1, so I divide it by 2. That also can give you is 4995. Okay, so this is the second approach. The third approach, it might be a little bit trickier. Okay, let's see. Let me erase this right here. Okay. So let's see the third approach. What I do here is, guys, you see, this is 11, right? Plus 12, plus 13, plus 100. I definitely want to use this formula because it's very quick, okay? But how can I use this formula to this? The thing is, do you see that I can actually split this summation into the sum of two pieces? In other words, 11 can be decomposed into 10 plus 1. 12 can be rewritten into 10 plus 2. 13 is 10 plus 3. 98 is 10 plus 88. 99 is 10 plus 89. 100 is 10 times 9 plus 90. Now, do you see that this is the sum of the first 90 integers, right? So that gives us is sigma k from 1 to 19k. So that gives us is 90 times 91 over 2. Okay? Do solve this. What about the top, guys? You have 10 plus 10 plus 10 plus 10. How many 10s? You add it together. Well, actually it's 90, right? So on the top, which is 90 times 10, right? Or if we write into the sigma notation for the summation of this, that is going to give you the sum k from 1 to 90, 10. Okay. As you can see, inside is integer, which is 90 times 10. And if you add those two together, those summation also will give you 4995. Okay, so those are the three different approaches for solving the problem. And as you can tell, guys, especially in mathematics, the method is not unique. Okay, always have more than one way to deal with that. I hope you enjoyed this video, and I'll see you next time.